Hello. What we're going to talk about in this session is how you performance tune your application once you've moved it from client server to installable cloud app. So the first thing we're going to have is, well, actually, is a disclaimer, and then we're going to look at the agenda. So the first thing I'm going to do there is talk about myself for a little bit, just so you know who I am. We're going to look at how you can tune up the performance of compilation and deployment of the application. Then we'll look at how you can tune the initial app loading, and then how you tune ongoing operation of the app. And then we'll have Q&A. So a little bit about myself. My name is Bruce Armstrong. I've been using PowerBuilder since version 1. I'm fluent in a number of other languages listed there. I'm also involved in a couple PowerBuilder related open source projects. I've listed a couple of those there as well. This is the company I work for, and if you want to know more about us, you can check out our website. So let's get into compilation and deployment. So the first option for speeding that up is what I like to call develop locally, deploy globally. When you're doing your initial development, it will help if you make sure that you can have, let's say, you do your deploys, your development deploys directly to your local machine. Run the web's APIs out of Kestrel running on your local machine. It could even help if you can get the database moved down to your local machine. The more you can isolate everything down to your local machine, the faster that you're, well, assuming you have the memory and horsepower for it, the faster you're going to be able to develop. If you have to deploy to a remote IIS server every time you make a change, things are going to slow down. That's just, the network getting in the way. But obviously, once you've done your development and you're ready to deploy, go ahead and do your deployment to your remote app servers. Have a production database off, certainly off your local machine that you deploy to for production. But for development, try to keep it local. Next thing you want to do is make sure, and this is checked by default, but make sure you have this option here in the application properties. It's under additional properties, and then there's a new PowerServer tab. Make sure you have this option checked that generates warnings about any features that you've taken advantage of in your PowerBuilder app that are unsupported. That way, you know in advance what you may need to go address. Otherwise, you're going to get surprised when you go to test your app and certain things don't work. So might as well, get the information earlier and deal with it rather than later. And then finally, use automated build processes. So there is a new feature added with PowerBuilder 2021, the auto build process, which will generate your client app and do your C# code. It'll generate that all for you. And the way you can implement that is you take your PowerScript project, and once you've got it created, when you can right click on it, and there's this option to export a build file. And then you can, and this is just stepping through that. So it's going to create this JSON file. And this shows what it looks like. And that's a little hard to read, so I actually am going to zoom in here a little bit. So this is the JSON file that's created, and I've made a few changes to it. So one of the things I've done here is I've added this pre-command, and what I've created is a batch file that deletes the source code in the directory that I'm going to be doing the build in. And that's the other thing I'm doing is I've added into the destination path, I've added in a subfolder in all the locations that's referenced. So that way, what this file does, it's going to connect to source control, and this is an encrypted password, and it's going to download the source code and then compile everything. So it's not working directly off what's in your PowerBuilder project on your machine. So what means, if you got the horsepower for it, you can be continuing to do development in PowerBuilder, but this auto build process can be connecting to source control and doing a build with what's currently in source control. And so you can fire that off and have that doing what it needs to do separately from the development work that you're continuing to do, if that makes sense. And the way you get this encrypted password is you run the auto build utility with an option that says show me what the encrypted password is, and then that's what you include in the build file. So this is pretty simple. This is just the command file I wrote to delete the source code. So each time it runs, it will delete the source code, re-download the source code from the source control system, and then re-perform the build. And this is the option I referred to, where you say pb auto build, and you say /p, and you give it the password to encrypt. In this case, I just put in the text password to encrypt, and that's what that ends up being encrypted to. But you would put in your actual password for your source control system, and you would get the encrypted password that you could use in the build file. And so this is let me zoom in on that one too. Running the PB auto build and passing in that JSON file, and then I've got some log files I generate as well. So debug errors and then unsupported features. Okay. Another option here for this, well, actually what we're doing now is we're looking at initial app loading. So one of the things you can do, it's a little less secure. You have to think about where your app is running at. If it's in an intranet and things are pretty secure, you might turn off encryption of the compiled P-code files, which is basically what you have when you have a client-server application today as well. If you're deploying to the intranet, though, internet, that is, you might want to turn that on just to protect your source code. But that is one option that would speed things up, because if the P-code files are encrypted, that means that when the app is initially loading, it has to decrypt those files. And it would, not encrypting them to begin with would save that step. Another thing that would help during initial app loading, you could turn off validation of application validity. That is intended to, it's basically doing a checksum of the downloaded files to ensure that they weren't tampered with. Once again, think about where your app is running. If it's intranet, and you're less concerned that somebody has somehow got a hold of your server and is manipulating the files, sure, go ahead and turn that off. When it's turned off, it basically operates the same as your current client-server application, which also doesn't inspect the application integrity. So this was a additional security feature added in PowerServer. You can turn it off, and the app will load faster because it's not doing that checksum on the files. Another option you have is in your PowerServer project, you have an option to preload files or dynamically load them as they're needed. So what this essentially does, if you move them out of the precompiled, or the preloaded, and into the dynamic, what it takes is it shifts that hit from downloading the files from the initial app load into the ongoing operations. So there is that downside, is that as users hit certain pages of your app that require those resources, they'll be downloaded at that time, and that will slow down the app at that point. Obviously, though, some of those pages may not be pages the user ever hits, and if they never hit the pages, they never see the delay. So it's just something you have to consider as a trade-off. Do I take the hit up front and have the app run faster on an ongoing basis, or do I accept a little impact on an ongoing basis to speed up the initial load? Another thing to look at is whether or not in the download options for the client, you download the files as necessary or all the files at startup. And once again, it's that same trade-off. If you download all the files at startup, your initial startup is going to be slower, but the ongoing operations is going to be faster. Conversely, if you say that it's going to be dynamic, then your initial load will be fast, but there'll be some portions of the ongoing app operations that will be slower. And this indicates what the impact of those two options are. One more thing to look at for initial app loading is whether or not the files that you are going to bring down and preloaded, whether they're be in compressed packages or in uncompressed packages. That makes a difference as well, since when you're going to access them, if they're in a compressed package, they're going to have to be uncompressed. The main difference here, though, is that if you put something in a compressed package, basically it's not something that you're going to be writing to because it's going to be accessed out of the compressed package. Whereas if you put it in the uncompressed section, you can modify it. It might be an INI file. It depends whether or not you actually write to the INI file. But anything you're going to write to, you want to have in the uncompressed section rather than the compressed section. Okay, last item on initial app loading. This is the runtime tab. And obviously, the more of these options you select, the more that's going to have to be downloaded to the client during the initial upload. So something to consider is, am I actually using these objects or these features in this application? And if you're not, don't check the option. Don't be downloading stuff that you're not actually using. Let's look at ongoing app operations. So there's two major things you look at here. One is minimizing the number of API calls. API calls are an expensive operation. If you have a page and that page is making numerous API calls before it loads, that is going to slow down the app. If you can get those API calls consolidated so that it only has to make one API call, your page will generally load much faster. Your app will respond much faster. Now, one way of doing that is if you've got embedded SQL in your PowerScript side, move that to a stored procedure, and then call it as a stored procedure. Stored procedures just tend to be faster since they are operating database side, and in some cases they are precompiled and will operate faster because of that. The other thing you can do is take the code, and instead, if you don't want to put it in a stored procedure, perhaps you can put it in a REST call. Once again, if you got something that's database intensive, you want to move that as close to the database as you can, not on the client side. Because if you put it on the client side, then all that database interaction is going through the REST API, and that's really going to slow down your application. So try to get all that database intensive stuff up into the database side, or at least into the C# side. So it's server side. Get the REST API call out of the picture, and it will improve your operations. Same thing with if you've got select statements and a for loop, any kind of operation that requires a lot of database calls. Try to re-architect that. For instance, if you're using multiple select statements in a for loop to retrieve a bunch of data, maybe you could do the same thing in a single data window retrieval call. The other thing you can do, if in addition to looking at the number of API calls, is the size of the API calls. The API calls cause a large impact, not only due to the number of them, but due to their size. JSON is a rather dense storage format, and it is generally compiled before it is sent down to the client, but it still can be significant. So one of the things you can do, and we'll look at this in a little bit more detail, is you can retrieve data incrementally. Now that may sound like we just contradicted what we just set up here earlier about minimizing the number of API calls. But it's a bit of there's a trade-off involved, or actually I should call it like a happy medium. We experienced this when we first moved our applications into a multi-tier. We had a client server app, and it was doing a lot of calls whenever it loaded up a window, and we said we can't have it doing that with REST API calls. It will take way too long to load. And so in our initial cut for a web app, whenever we had a window, we would wrap up all the initial calls into a single REST call. And for many windows, that made great sense and it worked great. But there were some windows where the amount of data we were retrieving for that window was so large that it was actually causing performance problems. So what we ended up doing is we took those windows in particular and we moved them into a tabbed view. We broke up the window a bit, so instead of being one long page, it was a page with multiple tabs, and then we would retrieve each tab as the user clicked on it. And so we got away with that huge initial load, and there was still some delay as they navigated through tabs, but it's just like that issue I brought up earlier. If the user doesn't hit certain tabs, you never retrieve the data, so you never take the hit. And so that's sort of the happy medium we're looking for. Reduce the number of API calls as much as you can, but once you've started doing that so much that you generate huge data sets, you might want to look at maybe leaving them as several calls rather than one call and finding that happy medium. And the other one, and this is just a big, I think it's almost obvious, but if you're retrieving data that you're not actually using, stop retrieving it. You may have just done a select all, select star in your data window just to keep things simple, but maybe you need to go back and look to see, are there 50 columns on this table and I only need 10. because if that's the case, you're bringing down another 40 columns you really don't need the data for, and that's going to slow down the app as you retrieve that data. So let's dig into this retrieve data incrementally bit. This is an example in SQL Server where you can use the offset X row fetch next Y rows only option to retrieve a subset of the rows returned by this initial select. And then what you can do is basically just paginate through your data. So you could, you may remember the retrieve as needed option for the data window. This is essentially doing the same thing, but you do it in your, in your REST API call. So your REST API, well, I mean, you wouldn't actually do it that way. You'd create a data window with this select, and then pass in different values for the starting row and the number of rows you want. But that would end up generating a REST call that would then incrementally proceed through the data, basically paginating through the data. And when the user initially loads the screen, they're probably only going to see a certain number of records anyway. So paginating through the data at that point won't necessarily seem to them to be a huge hit, rather than if there were 10,000 or 100,000 rows involved. If they had to sit there and wait while the client downloaded that many rows, they would notice it, and that's not something you want to necessarily do. One thing to note here: if this particular language structure is fairly standard, I put fairly in quotes there. Between databases, there are little nuances. For instance, in SQL Server, the order by clause is required. If you don't have an order by clause, you can't use the offset fetch language. Most of the other databases don't require that. Here's an example. This is Oracle. Or I do show the order by clause, but it's not required for Oracle, and it's the exact same syntax. This is PostgreSQL. Sorry, went too fast. Very same syntax. I've selected from different objects in the different databases, but that just shows you that the syntax is all the same. And as far as I know, PostgreSQL does not require the order by. And this is SQL Anywhere. Now their syntax is a little bit different. Instead of the offset, let me actually go back and look now. Instead of, offset 0 rows, fetch next, it's limit 3 offset. So it's a little bit different flavor in SQL Anywhere. And also the limit option is not enabled by default in SQL Anywhere. You actually have to turn it on using the public.reserved keywords equal limit statement there at the top. You don't have to put it in front of every statement, but you do have to set that at some point, and then before you can start using the limit keyword in SQL Anywhere. There's also some other variations. SQL Server and SQL Anywhere support a top statement as well, but that's a little less standard. The offset fetch is fairly standard across most databases. Okay, some more things for ongoing app operations. Once again, this is the idea of keeping things local, at least as far as the database. I mentioned earlier, if you've got intensive database operations, to move it close as the database as you can. So this is that same, pretty much that same statement. Try to get the C# code for the PowerServer C# code running on the same LAN as the database, because if you have to go outside the LAN, then those database interaction calls are going to be hit performance-wise. Another thing you can do here is make sure you publish the PowerServer Web API to Docker or Kestrel. The idea being here is that Docker and Kestrel are very lightweight containers for running the code. They don't have all the overhead of, let's say, IIS, and so they tend to operate a little faster. And you can use IIS as a front end to Kestrel, so that the calls are routed to Kestrel through IIS, but don't, from a performance perspective, you wouldn't necessarily want to try to run the Web API call directly in IIS. Run it in Kestrel or Docker instead. You could also use a PowerServer cluster and a load balancer to take, if your server's getting overloaded with calls, that's one way to scale up. And the last one I'll mention, and it's maybe the option of last resort, it's like throwing money at the problem, is if you are in a virtualized environment, you can always upscale the server. If you're in something like Amazon Web Services or Microsoft Azure, you may have started off with maybe a 2 CPU system and maybe 8 gigs of memory. But it's a virtual machine, and all you need to do in order to scale up the server, if you don't want to go to clustering, is just take the machine down, indicate that you want additional processors and additional memory, and then start it back up again. And it starts up again in that more powerful structure. It's not like you have to buy a new server and move all the code to the new server. You just bring it down, reconfigure it, and start it back up again. That's one of the sweet things about being in a virtualized environment. Okay, that's all I had, and so time for questions and answers.